So my favorite decomposition reaction is the decomposition of hydrogen peroxide. Now, I've got the little sign here for you. You can see that I've got hydrogen peroxide, 2 of those, breaking down into water and oxygen. There's 2 waters, 1 oxygen molecule. What you might notice, besides the fact that it's balanced and it's got its phases listed, is that this equation has something extra. Right here in the middle, it's got MnO2 kind of on top of the arrow. And what that means is we have a catalyst. The catalyst is not affecting the reactants or the products of the reaction, but it kind of changes the steps of the reaction in between so that it speeds it up. So we put it in there saying, yeah, it's here, but it's not changing what the original reactant and product was. So it's kind of a bystander in the equation itself. Now, to get started, I need to make sure that I can prove what I'm saying is happening here. So I'm going to try to catch some of the oxygen bubbles, which means I'm going to take some handy-dandy dish soap and put that down into this graduated cylinder. What that should do is make bubbles and catch those bubbles so that we can see what's in them. Now, if we didn't have the catalyst, this would still happen, which is why you want to refrigerate your medical hydrogen peroxide at home, because over time it does break down into oxygen and water. So if you're trying to, disinfect a cut and it's old hydrogen peroxide, you could just be pouring water on it. So let's watch. This is exciting. Do you see the bubbles forming? Yeah, it's really slow. So that's why we want to use a catalyst. Speed this up. So we've got our soapy hydrogen peroxide. We've got some bubbles on the top. We don't know if those were created from the hydrogen peroxide or just because we put the stuff in and it kicked some air up. But if we sat here long enough and watched it, we would see a difference in the amount of bubbles that are on top. However, we don't have all day, so we're going to take just a little bit of this manganese dioxide and we're going to put it into, there we go. Now we can see. So what we're watching is the decomposition of hydrogen peroxide into oxygen and water. Now the water is kind of going to be sort of mixed up in here and down there, but the oxygen is pretty obviously going to be stuck in the bubbles because it's a gas. How can we test for oxygen? Oxygen helps things burn. So I'm going to light up my little match. Hopefully I don't catch my plastic gloves on fire. And I'm going to try to see if this helps things burn. It certainly does appear to not be going out. Oops. Didn't want to burn my gloves. With the moisture that's around these bubbles. And as it slows down here and makes bigger bubbles, it's very challenging to light matches with plastic gloves on without lighting the plastic gloves up. Latex, whatever. So you can see that I can burn these bubbles, which means they must have oxygen in them that allows them to burn. So we've proven that there's oxygen there. Just going to have to take my word for it on the water. Now the reason that it's really important for me to wear these annoying gloves for this reaction is that hydrogen peroxide, especially since this stuff is 30%, which is 10 times as strong as the stuff you'll have in your medical cupboard at home, is that it will kill living tissue. So do not try this at home, because I don't want a lawsuit. However, I do love burning bubbles because it's really fun. What I'm hoping is that as this slows down a little bit, ooh, that was fun, I should be able to drop a match into here and you can really see it light up. Whoops, there went my gloves. All right, it's slowing down. As it slows, you can see there's a very clear burning going on with the match, so it's not just the match is burning normally and I'm just talking trash. You can see that the whatever's in here is helping the flame to burn higher. There we go. That's kind of fun. All right. I could sit here and play with this all day, but I guess I can't. So, decomposition, hydrogen peroxide turns into water and oxygen. We proved that there was oxygen here. A little bit scorched. We proved that there was oxygen here because we could light it on it. We could light the match brighter when it was burning near the bubbles. And we used a catalyst which sped up the reaction without actually changing the reactants and products of that reaction. You can see, if you look closely at all this mucky stuff, that there's black powder, the same as the magnesium dioxide that we put in here. There's still black powder here. When you use a catalyst will be at the beginning of the reaction and at the end of the reaction in equal amounts. It doesn't get used up by the reaction, which is how we know that it's not actually part of the original reactants and products. It just sort of helps to make an easier route for the reactants to become the products. So, decomposition, H2O2 style.